Hey, good evening, guys. Thanks for coming for our session. So let's go. How awesome is that bike? Um, who owns a trek bike over here? Oh, cool.
That's awesome.
That's awesome, yeah. So the topic of today evening session is accelerating retail analytics using Azure, Databricks, and Qlik. So something about ourselves. I'm Advait. I'm the team lead for data engineers. I have an amazing group of talented data engineers and reporting engineers I get to work with. And regarding that picture, I had just started at Trek 2016 back in the day, got my new bike, clipped in for the first time, and, and I'm guessing you guys know exactly what happened. There was a stop sign right before entering our Trek campus, and I forgot I was clipped in, and I went down. So the moral of the story is there are some days where you can pedal slow, there are some days where you can pedal fast, but you have to keep pedaling, especially if you are clipped in. So I'll hand it out to Garrett for introduction.
No, you can hold on to that.
Yeah.
Hi, everybody. I'm Santa Claus in the picture, Garrett Baltzer. I've been with Trek for 9 years now. Number of different roles I've served on the team. So started as a business intelligence analyst, took a detour into leadership for a few years, and then ended up in data engineering and data architecture, and I'm just here to have all the fun. So I'll hand it back to Advait as we move forward.
Cool.
Thanks for coming.
Thanks. So, Trek bicycle, the high-level overview. So Trek was actually born in that red building, the Red Barn, back in 1976. One of the co-founders used to live in Milwaukee, Wisconsin. The other one used to live in Madison, Wisconsin. So they found this little place in Waterloo, Wisconsin to start their biking endeavor. And that's where Trek was born in 1976. Very humble beginnings. Today, as we all know, we are a global leader in bicycle manufacturing, distribution, and retail. We have significant retail presence across the globe. Pretty much have retail stores in all the continents except Antarctica. Huge independent dealer network. And our mission, right? Our mission is to build only the best products, offer incredible hospitality, and change the world for better by getting more people on bikes. So yes, these are some of our awesome products. We all know Trek makes some of the best bikes in the world, as you can see over there. That's my favorite bike. It's a Trek Checkpoint. Extremely versatile bike. You can use it for day-to-day road riding, gravel riding. But the products I'm truly proud of are some of the safety accessories Trek makes. Like this wave cell helmet that you guys can see over here. That wave cell helmet has these crumple zones built into it. So what happens is, if in an unlikely event of a fall, the crumple zone, just like your car's crumple zone, takes all the pressure and actually keeps you safe. Our tagline for this product is, "You only got one brain." So great product, very proud of this product. Another product we just launched is this product over here. This is a high visibility light, but also within it is embedded a radar. It's a radar that tracks all the cars that are coming from behind, and it actually integrates right with your Trek app. And it shows on your app how far behind the car is as it approaches you. So that product is known as car back, because cyclists will scream car back when they see cars coming. So these are products which actually make cycling more safe and gets more people on bikes. So moving on. So today's topic is accelerating retail analytics. We are a Microsoft Azure BI shop. Qlik, Replicate, and Databricks are our partners. Within Databricks, we use the whole gamut of their products like Delta Live Tables, Databricks SQL, Lakehouse architecture, streaming, all of it. And what I've been told, we fall under retail and consumer goods section. So for today's presentation, at end of what we're going to show, we were able to achieve an 80 to 90% acceleration in our retail analytics. We were able to increase our data warehousing workloads by 3 times a day instead of 1 time a day, and were able to get near real-time replication of our ERP data, going down from like once a week to near real time. And we are kind of very much aligned with our leadership's goal of being cloud first. So agenda and objectives for today. So I'm going to start out with some of our challenges we faced with our retail data growth. And then I'm going to talk a little bit about the cost performance matrix. And then Garrett is going to cover all these cool technical topics over here regarding our old architecture and new architecture. And then we will together close out with lessons learned and some time for Q&A. So challenges faced by Trek. So we had an extremely slow replication of ERP and POS data. We used some legacy technologies that had some challenges. Then the ERP and the point of sale data was stale on our lake. So it used to take some time to get analytics insights. Then the rising data warehousing cost and performance issues. And it was difficult to scale our analytics and retail POS data, as well as analytics on our ERP data. And then there was a lack of global unified view of our data. So what was the impetus to do all of this? It was rapid expansion in our retail footprint and retail ecosystem, starting with trekbikes.com, our website, which we use for both B2C as well as B2B. Obviously, the size of the data captured by our website is huge. Also, there was a significant increase in our retail focus. So, there was significant expansion in our retail stores as well as our independent bike stores network and bike dealer network. Our point of sale data, our silver layer, that's what we call, more than 10 terabytes. I just was informed by one of our DBAs last week that our ERP data has crossed 8 terabytes. Even our, for one specific analytical solution, even our compressed, highly aggregated gold layer, that's crossing more than 500 GBs, almost reaching a terabyte. So at such data volumes, a standard SQL server on an on-prem server, or standard SQL on on-prem server, or a standard SQL server on an Azure VM or any cloud VM for that matter, as well as like an Azure SQL data warehouse or SQL server, just simply doesn't scale at that costs. So that was one of the impetus to get into Databricks. So that leads me to this cost performance matrix. This is one of my favorite slides. So on your y-axis, you got performance. On your x-axis, you got cost. And the two extremes, right? Like low cost and low performance, and high cost and high performance. Those are usually the choices company make. Either they can choose to stay in, not pay and have poor cost, or they choose to pay and have great performance. But most of the companies, at least we found ourselves in not so good quadrant, which is high cost and bad performance. Our SQL server, our Microsoft Azure infrastructure simply couldn't scale. And our goal was to keep moving kind of up to the left in a low cost and high performance quadrant. So our goal over here was to deliver high data warehousing performance at either the lower or the same cost. So with that, I'm going to hand it over to Garrett.
Yeah, absolutely. So we didn't start in the high cost, high performance area. And what I want to highlight here in our old architecture, and maybe take a journey back to 2017 when we implemented this architecture, our retail team approached us and told us that they were going to start acquiring stores and implementing greenfield stores for direct own to retail. And we didn't have an idea at the time of the scale of stores that we would implement. So using the tools that we had in our tool belt and being in Azure, from the ERP perspective, we implemented a custom program that we had running on-prem, and we just basically duplicated that to download that information into CSV format to a large Windows server. The Windows server is and was very expensive, and using BCP, we would upload that information into our ADLS Gen 1. That was back in 2017. There was no Gen 2 for ADLS. And from there, we would polybase that information into Azure Synapse Data Warehouse, or Dedicated Pools, I believe it's called now, formerly SQL Data Warehouse. So been rebranded 3 times, and then from there, we can simply consume that information into our semantic layers. At the time, it was Power BI, and we were using OLAP cubes. We used primarily multidimensional OLAP cubes. So a very costly process. To make things worse, it was full loads, so it would take anywhere from 24 to 48 hours. If you ever had to watch something, babysit it per se, it's not something fun to babysit. So that was that process. And then to make our retail analytics work as we went into this, right, the ERP information really enriched it from a wholesale perspective to our stores, as well as some of our master data, but then you get to the point of sale information. For those of you that don't know, Trek actually owns a point of sale. It's called Ascend RMS. We purchased it before we actually went into direct owned stores at a larger scale. At the time, we only had 2 locations in the Madison area. So we were familiar with analytics from a retail perspective, but it was only for 2 locations. So from there, we actually implemented the same process. So we have that just basically a rewrite for a different format of database, but that .NET application would download that information to another costly VM. This one sat in Azure versus on-prem. And again, we would bulk copy that information into our Gen 1 data lake. The thing that's different is as we scaled, we had other POS systems that we had to integrate. If you're familiar with Lightspeed being an example, right? When we'd acquire a store, we didn't always get our point of sale system. So we'd have to figure out how to implement extraction and loading that information into our data lake. And that was also daily loads, and it was also overwrites and or full loads. So vendor APIs would be things like Retail Next and or foot traffic, where we download information so that we can better enrich our analytics for our retail team. So again, we polybase that information into Azure Synapse and Data Warehouse, and that information can then go back into the OLAP cubes and be used for our downstream reporting tools, Power BI, Excel, SSRS. Again, it was 24 to 48 hours. Something failed, it was a long process to get it working again. So that gets our ERP and our point of sale information into Azure Synapse, where we can combine it and then build out these multidimensional solutions for our business to consume. So fast forward 2022, 2023, the solution overview that I'm going to dive into. So we've since migrated to Azure Data Lake Gen 2. As you know, Gen 1 is no longer available, but Gen 2 gave us a lot more control over our information with hierarchies and things like that. At the backbone of what we implemented was Azure Databricks Data Intelligence Platform, and we use the whole gambit of the stack here to produce the analytics using Spark, right, for its powerful compute, Delta tables for its reliable format, and Photon, which really supercharges our information. The lakehouse architecture, we do follow the medallion architecture. It allows us to combine our data lakes as well as our data warehouse and We have Databricks SQL running. We do use that for quite a few things, but it is very reliant, performant, and allows our analysts to access information using a standard language that they're used to. Spark streaming, autoloader, which is one of my favorites, and Delta Live tables allows us to have reliable ingestion of information, always keeping it up to date. And Unity Catalog, it's nice to have a product that just works and you don't have to do a ton of additional things, especially from a governance perspective. So added a lot of value at a very low cost for us to implement. So from a replication standpoint, from our source systems, we implemented Qlik Replicate. If you're not familiar with it, the Qlik guys are here. That is a CDC product that reads from our JD Edwards IBMI, and it loads directly into Databricks and into Data Lake. I'll jump to that in the next slide, but we use Fivetran as well. Fivetran is used to extract information from APIs for us, and as well as Azure Data Factory. So, and then we also upgraded our semantic layer. We use Power BI still, but we added at scale to the mix. So, why did we choose Databricks? That's a good question. So we had the opportunity to look at what we were doing and why we were scaling. I mean, we were paying for the solution, it was growing, but we really needed to optimize for cost. But we also wanted to embrace the open source paradigm. Our leadership at the time was very open to that. We wanted to adopt Apache Spark, the universal data format, and then being able to use Python and Scala, just such rich ecosystems for analytics. For us, it really did enable us to do quite a bit more. That separation of compute and storage, that is super valuable for us. Not everything for us runs real time. Like a lot of shops, we're batch, and so separating that allows us to scale each one independently, saves on costs. We do get to go cloud agnostic, even though that we are talking about Azure. We have stepped into GCP and other providers, so if there is a need to move, we can move. We're no longer stuck and bound to a single cloud provider. So moving away from vendor locked-in data formats, I'm sure if you guys have been in it, you've been familiar with that. Being locked into something's never fun. Adds significant time for projects and migrations and things like that. So getting away from some of that and moving to a more universal. And then the lakehouse architecture, just the best of the lakehouse and the data warehouse, when they came out with Delta format, having ACID transactions, that was a game changer for us. And we had a need for a unified analytics platform. We've been pretty fragmented over the years and a hybrid approach and a lot of SQL servers laying around. So that's why we chose them. And if we take a look at our new architecture for our ERP replication, so the big thing I want to point out here is the Qlik controller node replaced the Windows server. When we implemented Qlik, we really only need a very small controller node, and that gives us a very powerful interface for replication. Very easy to use, it's easy to configure, and it basically took our replication from 24 to 48 hours, and roughly around 12 to 24 for that portion, to under 10 minutes. So now we have our data in under 10 minutes from our ERP system in our Databricks Lakehouse and our ADLS Gen 2, making it accessible. So immediately we just sped up the whole process. We also get their support, which is extremely valuable to us. Custom applications don't have support. If you've had them, and you have to fix them yourself, it's never great. So. And then from there, we can build out our medallion architecture and ingest that information into OLAP and Power BI, and now added at scale as a semantic layer. So, and then taking a look at our new architecture for our point of sale replication. So at the same time all of this happened, our vendor and our point of sale system did update some of their stuff, streaming information using Azure Event Hubs in near real time. We also have an internal data integrations team, which could also help us in facilitating landing vendor API information in real time into our ADLS Gen 2. So we were starting to get this information streamed to us in the ADLS Gen 2. Fivetran also facilitated some of that. And so the first step in there is to create our bronze table, which is really just our underscore raw tables, few additional pieces of information attached to the information that was streamed. Our silver layer, which is our clean tables, the thing I'll point out there is that the replication tools are streaming to us, the Qliks, the Fivetrans, and our data factories are streaming our silver layer to us. So we do bypass the bronze layer with those tools. But from there, then we take that and we create our gold layer, which is really our facts and dimensions, following the Kimball style. And our users can then access our information, and we can produce our analytics using Databricks SQL, Power BI, and at scale via Excel. So really took the whole process down to only a couple hours. So enabling us to, like Advit said, run the solution 3 times a day. We do that for global purposes, right? We're global and we want to have our information updated for each region of the world at their start of their day so they can make business decisions. So we can now run it more than that if we wanted to, which is super nice. And then if we jump into our streaming use cases and what that looks like, so Delta Live Tables is our streaming use case. We can land information into our ADLS Gen 2 basically in any format. So if we have vendor information from third-party point-of-sale systems that we use around the globe. Our point-of-sale system isn't tax compliant in every country, so we do have to implement. So we do stream that information into our ADLS Gen 2. Sometimes it's in JSON format, sometimes it's CSV, sometimes it's XML. Autoloader really facilitates helping us load that information pretty easy and seamlessly, just using SQL or Python in a notebook, a few lines of code. And then basically it allows for the checkpointing and the incremental loading. We can run that either continuously, or we can simply run it as a batch process and it'll start where it left off, making it super efficient. No more full loads, things like that we were doing. So after that, right, those Delta Live Tables do process, the bronze, silver layers, and sometimes the gold layers. Sometimes we'll create the golds in different ways. Let's see, and then it's Unity Catalog enabled. So the use case that I have for my first one that I wanted to highlight is our call logs and call management system. The data is landed in CSV format. This is landed once per day. But you can see that we have on the top right the Delta Live tables creating our bronze and silver layer. And then we have a separate process here. Once the silver layer is finished, the workflow fires a notebook that'll create our facts and dimensions, which really, and those are in the Kimball style. And after that, we do use the APIs with Power BI to trigger a refresh. So the entire workflow can refresh all the way through to the Power BI side, producing the information, but also another key thing that is really beneficial I didn't mention previously is the schema drifts. It handles all that for us. It keeps things nice, clean, tidy for us, and we don't have to think about it too much. So really efficient and easy to use. So, and the next one from a retail analytics standpoint that I want to highlight is a hybrid streaming and batch use case. So we had a need for our retail store employees to interact with information. And so we took our gold layer, we ingested some of that information into Power BI. Our retail employees, we built an interface for them to actually interact with the report, and they can provide feedback. That information and that feedback triggered from the report gets logged into our ADLS Gen 2. That's done through a logic app. And from there, there's two pipelines we implemented. They're identical DLT pipelines, but they run on different schedules and they have different purposes. So on the top side, you can see that I have a continuous stream. The continuous stream is actually true streaming. It happens from 8 a.m. to 5 p.m. Central Time. So when our stores are open, their busiest hours, and our retail employees are interacting with the report the most, we have it run in true streaming mode so that it can actually update the report in real time. After that, at 5 p.m., we do switch it to a batch process, so we turn off the continuous stream and we turn on the triggered version, and we trigger it every 3 hours to update. And from there, we have a classic SQL warehouse that is always on. The classic SQL warehouse is used for the Power BI report to interact and grab data from a direct query perspective. And so what they're doing is logging information, but then everybody else needs to see it. So it direct queries to grab that information that we're processing from those DLT pipelines in real time, so that not only that store and that employee know what they did, but all the other stores and other employees using the report know what they did. So that report generally has roughly 5,000 plus interactions per month that get logged and then get reflected back into the report. And then just a look at Databricks SQL and what we're doing with that with some of the solutions. So here we're capturing some of the telemetry information from our Azure and the solutions we're producing. As Advit mentioned, our ERP system's pushing 10 to 12 terabytes. Our other solutions are pushing more. This is grabbing telemetry, and we're using Databricks SQL for aggregations here to better monitor our storage associated with our Azure Data Lake itself. As you can see on the right side, we have a significant peak that dropped off. That's right around the time we built the report, and we had a need, right? We saw our costs increasing from a storage perspective, and we didn't know what was causing it, so we implemented a DLT pipeline with capturing this telemetry and built the aggregations and used Databricks dashboarding to build out the dashboard so we could better understand where the variations were coming from, and then we could simply implement our optimizations and vacuuming of the storage to reduce those costs. And it does have a significant impact at those sizes when you start to reduce your storage to what you actually need. And then Unity Catalog. So as we went through this process and implemented, at scale or more modern semantic layer, things like that, we did have a need to move. We started out on an original workspace back in 2018, 2017 in Azure. Unity Catalog was not enabled. So we took the time to evaluate what we wanted things to look like. And so we actually, and I'll use the word migrate, we migrated to new workspaces and moved some of these workloads in this scenario, we stood up new Unity Catalog workspaces enabled, and we moved the workloads from Azure Synapse over here. This is so that we could have separation of workspaces. We could start to leverage some of what Unity Catalog had. Engineering teams have their own workspace. Our analysts have their own workspace, right? Our data scientists have their own workspace, but it's all the same data, just powered through Unity Catalog, exposing it in different locations. It also enables our CI/CD pipelines and having different catalogs for prod and development workspaces. And then in the top right, one thing that's my favorite is the lineage tracking. If you're ever trying to use SSIS and SQL Server and try to figure out where you manipulated a field and what you did differently, it's super complicated. But here you can just continue to drill through. It reads everything, all the artifacts inside the workspaces, and can tell you exactly what changed and where it changed. So super valuable to have. You don't actually have to do anything different other than just use a Unity Catalog workspace to have that feature. And then down on the right, you get some more insights associated. We have started playing with the quality. We haven't traditionally monitored our quality of data as it funnels through, but we have started implementing those quality monitorings and are looking to evolve that more so that we can ensure, right, when data runs through these pipelines, there isn't a drop-off or a significant change within the data, so that we know before our customers know that something is off with our information. So I'm going to hand it back to Advit to wrap up the last few slides.
Thank you, Garrett. So some of the key principles for effective technology integration. First and foremost, what we realized, at least at Trek, is you don't do tech, AI, or this data stuff just for the sake of doing it. It has to align with our company's mission and values. And we're trying to ultimately do all this cool stuff so that we can get more people on bikes. The second is we have an amazing support and sponsorship from our execs and our leaders. So that is very key to get such projects going. Then we have a pretty good team with great SQL, Python, and Scala pipelining skills. And then shout out to our Databricks and at-scale partnership we have. It's critical to have great relationship with account managers and solution architects. And then before we delve too much, it's time sometimes, it's okay to sometimes pause and understand the theory behind distributed computing, because if you come from SQL Server world, Apache Spark is a little different. So taking time to understand distributed computing, Databricks Academy has some great courses there. Then making sure your underlying delta tables are fully optimized, they are clustered, they have auto-compacted. We recently transitioned from a Hive partition table to clustered table, and the performance was mind-blowing. So then try to use job clusters. They are amazing. And then the cost is less on job clusters. They will shut down once the job is done, and you can tag them so that you can track the cost in your Azure cost portal. Then you want to make sure you use efficient use of Photon and AQE, adaptive query execution. Generally, you come to know whether to use Photon or not to use Photon after some experimentation. Then make sure you use reserved instances. Try to figure out how much of compute you use in, say, 6 month or a year time span, and then depending on that and what projects are coming in future, you can reserve that compute for next year and save some cost there. And then my favorite topic is cost awareness around storage. When they tell you that storage is cheap, I think that's a lie. Storage is not cheap. When you're talking terabytes of data, it all adds up. I was asked by my manager just before the budgeting season, why are we spending so much money on a data lake Gen 2? Shouldn't that supposed to be very cheap? And the answer to that is no. And that's the reason you have to make sure that you keep your tables fully vacuumed, make sure the tables are correctly partitioned and all the historical ones are in cold storage and things like that, because when you're talking like a 300 GB table, it all adds up, and you have hundreds of them, so it all adds up. Then emphasis on CI/CD pipelining. We use Bitbucket, Atlassian Bitbucket but I know people use GitHub or whatever. I know Databricks integrates natively with most of the major CI/CD tools, so make sure you use those. Then again, one of my favorite points is keep things simple. So we just try to stick with simple Kimball data modeling, old school data warehousing, facts and dimensions. Don't have to reinvent the wheel, throw all these big words like data mesh and all of that, In our place, it's just basic facts and dimensions. Works great. And then prioritizing data quality and data ownership over AI and ML. I was at Qlik conference last week, and one thing I took from that conference was, during the keynote is you do not get to skip to the end. You don't get to do data, AI and ML and LLM and all these things without you having a good data warehouse, good data replication, good data quality, and things like that. So focus on basics, basically, of data. Have data strategy first before having an AI strategy. And then actionable insights for frontline employees, right? We are doing all of this so that we can provide all these insights to our frontline people quicker, faster, in a cheap way, so that those guys can actually take actions from this data and actually, get more customers on bikes. So, and then those guys have to be empowered to take decisions. So, so these are some of the key things we learned from this project. So in conclusion, we got a 100% adoption of Databricks and Qlik replicate, near real-time replication of ERP and point of sale data, elimination of daily and weekly lags in our data, substantial reduction in Azure spend because we were able to turn off a lot of Azure VMs we didn't need. Lift and shift methodology only works up to a certain point. At some point, you just have to re-engineer it. You cannot just shift your on-prem stuff to cloud. It needs some re-engineering. And then drastic improvement in our runtime and SLA compliance, increased workloads. We went down from 1 to 3 times a day, daily refreshes. And the most important thing is, our quality of life, right? Like most of these solutions we have built on Databricks simply run, and we don't have to worry about it. So.